Hi, in this video I will solve the computer exercises of chapter number 4 of the book Introductory Econometrics, and the chapter name is Multiple Regression Analysis, and I have attached the PDF file of these computer exercises in my description box, so you can get it from there. So let's start. I have set up the working directory in the econometrics folder in the D drive. Press Ctrl plus Enter and then make sure to install these packages. There are 5 packages that are going to be used in this exercise, and the packages name are Woolrich, Stargazer, Car, Deployer and Core. Then press Ctrl plus Enter and then call all these libraries, all these packages through library function. Press Ctrl plus Enter and then make sure to type this command options and the bracket scipen equals to 999. This will make sure that all the results, all the output are presented in normal numbers and not in scientific notations. Okay, so let's start with the question number 1. The first question utilizes the dataset vote1 from package Woolrich. So call this dataset through data command. Press Ctrl plus Enter and then attach this dataset. Now what it says, what is the first part of the question? In this equation, vote A is the percentage of the vote received by candidate A, and expenditure A and expenditure B are campaign expenditures by candidates A and B, and PRT by STRA is the measure of party strength for candidate A. So what is the interpretation of beta 1? So you can see that the beta 1, it is here, it is the coefficient of the variable log expand A. So therefore through using equations, given equations in the book, we can say that what is its interpretation? It says its interpretation can be change in vote A equals to beta 1 divided by 100 into percentage change in expand A. Okay, so it means that beta 1 divided by 100 is the ceteris paribus. It means that holding other factor fixed, beta 1 divided by 100 is the percentage point change in vote A when expand A increases by 1%. Okay, now let's look at the second part. In terms of the parameters, state the null hypothesis that a 1% increase in A's expenditure is offset by a 1% increase in B's expenditure. We can state the null hypothesis in this way: HO colon beta 1 plus beta 2 equals to 0. Okay, beta 1 plus beta 2 equals to 0, and it essentially means that certain percentage increase in expenditure by A and a certain percentage increase in expenditure B leaves vote A, the percentage of votes received by candidate A remains unchanged. Now let's look at the third part. It says that estimate the model using the data in vote 1 and report the results in usual form. Do A's expenditure affect the outcome, and what about B's expenditure? Can you use this result to test the hypothesis in part second? So let's create a model by the name of vote underscore model, and then use this assignment operator, and then vote A tilde log expand A plus log expand B plus party strength A. Press Ctrl plus Enter and then summarize this model. In this we can see that the R squared value is 0.7926, that is 79.26 percentage, and the intercept is 45.07. Coefficient on log expand A is 6.08, and the coefficient on log expand B is minus 6.61, and the party strength A is 0.15. And now look at this t value and the corresponding p values. The star symbol here indicates significance of the coefficient. So the coefficient on log expand A, that is 6.08, is very significant. Okay, it's significant at 1% level. And look at the coefficient on expand B, log expand B, minus 6.61. It is also very significant. So the estimates imply that a 10% ceteris paribus increase in spending by candidate A increases the predicted share of the vote going to A by about 0.61%. Okay, and similarly a 10% ceteris paribus increase in spending by B reduces vote A by about 0.66 percentage points. So both of these coefficients are very significant. Therefore, A's expenditure also affect the outcome and B's expenditure also affect the outcome. Now, look at this other part, last part of this question. Can you use these results to test the hypothesis in part second? No, we cannot, because we do not have the standard error of beta 1 cap plus beta 2 cap. Now look at the fourth part of the question. It says to estimate a model that directly gives the t statistic for testing the hypothesis in part second, and what do you conclude? So for this question we will have to create a new variable. Now look at this. Let's create a variable by the name of theta 1 and let it be equal to beta 1 plus beta 2, or we can also say that beta 1 equals to theta 1 minus beta 2. Now plugging this into the original equation and arranging gives vote A cap equals to beta 0 plus theta 1 becomes the coefficient for log expand A, and beta 2 becomes the coefficient for the new variable log expand B minus log expand A, plus beta 3, which is the coefficient of party strength A. So we will have to create a new variable log expand B minus log expand A. Now we are in the R studio. Create a new variable by typing vote1, which is the dataset name, $sign A underscore B. Use this assignment operator and then log expand B minus log expand A and press Ctrl plus enter. Okay. Now let's create a new model by the name of new vote underscore model and then use this assignment operator and then type lm linear model vote A tilde log expand A plus use this new variable name A underscore B. You can name it by any name you like. Okay, I have named it by A underscore B plus party strength A. Press Ctrl plus enter. Object A underscore B not found. Why is this? Okay, since we have created a new variable, we will have to again attach this dataset. Again attach the dataset vote1 and now create a new model by the name of new vote underscore model and then press Ctrl plus enter and then summarize this model. Now in the equation we had seen that the theta 1, the new variable we have created, was the coefficient of log expand A. Now look at this coefficient of log expand A. It is minus 0.53210, and is it significant? No, it is not significant. The p-value is 0.31, which is way beyond even 10% level. Okay, and the standard error of this coefficient is 0.53. Therefore, we fail to reject this null hypothesis that beta 2 is equal to minus beta 1. Okay, so we fail to reject this hypothesis that we had undertaken in the part 2 of this question number 1. Okay, so we are done with this data set. We can detach this data set. Now let's come to question number 2. In this question, the dataset is being used by the name of laws ch85. So call this dataset by using their data function and attach this dataset. Now what is the first question? Using the same model as in problem 4 in chapter 3, state and test the null hypothesis that the rank of law schools has no ceteris paribus effect on median starting salary. Okay, so the problem number 4 in chapter 3 was estimating the salary on the basis of various variables such as GPA score and the rank of the college. Okay, so we have to state the null hypothesis that rank of law schools has no effect, so therefore the coefficient on that variable should be equal to 0. So this is the way we have stated our null hypothesis: h0 colon b5, that is beta 5, equals to 0. Now let's look at the second question. Are features of the incoming class of students, namely LSAT and GPA, individually or jointly significant for explaining salary? Okay, So let's create a new model by the name of law underscore model. Use this assignment operator, then lm. So log salary is the explained variable, and then tilde lsat GPA, and then log. This is new variable libvol libvol, and plus log cost plus rank. Press Ctrl plus enter, and then summarize this model. So what is it saying? It's saying that are they individually or jointly significant? Let's see their individual significance. The coefficient on L set is 0.004, and we can see that the p-value is 0.24, so it is not significant. And the GPA coefficient is 0.24 and it is significant. Okay, the p-value is 0.006, so it is significant at 1% level. To check their joint significance, we can create a new variable by the name of my ho, and then use this assignment operator, and then use this combined operator, and in the bracket type in the quotes lset equals to 0, gpa equals to 0. So this is our null hypothesis, and then use this function linear hypothesis from the car package. Okay, and then type the model's name. The model name is law underscore model, and then comma, and your hypothesis my ho. So look at this f statistic. It is very significant. It is significant at 1% level. Therefore, these two variables are jointly significant. And when we look at their individual significance, LSAT is not significant, but GPA is significant. Okay. So let's move on to the next question. It says test whether the size of the entering class size, or the size of the faculty needs to be added to this equation. Carry out a single test. Okay, so now create a new model by the name of new law underscore model, and then just add these two new variables, class size and faculty. Press Ctrl plus enter, and then summarize this model. So this is the coefficient on class size 0.001 and the p-value is 0.38, so it is not significant. And the coefficient on faculty is 0.00006 and the p-value is 0.86, therefore it is also not significant. So the question says carry out a single test. It says it is saying to check the joint significance. So now let's create the variable. I have also named it as myho, because every time we have to check a new hypothesis, I am naming it by myho, and then use this assignment operator, and then use this combined operator, and then class size or faculty. Class size in the double quotes, comma, faculty in the double quotes. Press Ctrl plus enter, and then type this function linear hypothesis in the bracket, type the model's name, and then your variable, then your object. So in this case, f test, the p-value on f test is 0.39, so they are jointly insignificant. Okay. Now look at the last part of this question. It says what factors might influence the rank of the law school that are not included in the salary regression. Okay, already there are many variables in this equation, but we could have also accounted for gender or racial composition across schools, and we could have also included faculty quality, which can be measured by publication records, etc. It can also be included. Okay, so such things do enter rankings of law schools. So we are done with this question. So let's detach this data set. Press Ctrl plus enter. Now let's come to question number 3. It says to refer to computer exercise C2 in chapter 3. It says now use the log of the housing price as the dependent variable, and in this question the dataset is being used hprice1 from the package Woolrich. Press Ctrl plus enter and then attach this dataset, and now let's create a model by the name of house underscore model, in which the log of the price is being used to determine, and it is being determined by square feet and bedrooms. Press Ctrl plus enter and then summarize this model. We can see that the intercept on in this model is 4.766, and the coefficient on square feet is 0.0003, and the coefficient on bedrooms is 0.028, which is almost equivalent to 0.029. Okay, now let's see what it says. You are interested in estimating and obtaining a confidence interval for the percentage change in price when a 150 square footage foot bedroom is added to a house. So in decimal form, this is equivalent to theta 1 equals to 150 into beta 1 plus beta 2. Use the data in h price 1 to estimate. So we have these values. We can estimate the price of the house on the basis of this new information. The square feet is being added is 150, which is being multiplied by the coefficient beta 1. So beta 1 we have here 0.000379. Okay, and the beta 2 here is 0.0289. Press Ctrl plus enter. So here is the value of theta 1 cap 0.0858, which means that an additional 150 square foot bedroom increases the predicted price by about 8.6%. Now let's look at the second part of this question. It says to write beta 2 in terms of theta 1 and beta 1 and plug this into the log price equation. Okay, so now let's look at this table. Look at this screen. Here beta 2 equals to theta 1 minus 150 beta 1, and so putting into the original equation we have log price equal to beta 0, which is the intercept, plus beta 1 square feet minus 150 bedrooms plus theta 1 bedrooms, and this is the error term. So theta 1 becomes the coefficient for the bedrooms variable. Okay, and we will have to create a new variable for the equation square feet minus 150 into bedrooms. So now let's go to the R Studio. Here let's create a new variable by typing the dataset name h price 1. Use the dollar sign to add a new column and give it a name new variable. Use this assignment operator and then square feet minus 150 into bedrooms. Press Ctrl plus enter and then type the model's name new house underscore model. Use this assignment operator and then lm log price and tilde new variable plus bedrooms. And then okay, since we have created a new variable, we will have to attach this dataset again. Go to this line 41 where we have used the attach function and the bracket is the model, the dataset name. Attach h price 1 again. Now we can press Ctrl plus enter. We can execute this command new house model and then summarize this model. Here we can see again that the coefficient on bedrooms, that is theta 1, is 0.0858. okay, and we are done with this question. We are done with this part. Now let's look at the third part. It says to use part to obtain standard error for theta 1 cap and use this standard error to construct a 95% confidence interval. So the standard error for this theta 1 cap is 0.026. okay, and we can use a function from the stats package in the R Studio to determine the confidence interval of this variable. Use this function conf int conf int and in the bracket type the model's name new house model and in the double quotes type the variable's name, that is bedrooms. Okay, press Ctrl plus enter. So here is the 95% confidence interval of this variable, which ranges from 0.032 to 0.139. okay, so we are done with this question. Let's detach this dataset. Thanks for watching this video. If you like my videos, then subscribe to this channel, and also you can follow me on different social media platforms. I have mentioned this link in my description box. Thank you.